Motion question 5. The diagram shows a roller coaster track. Part A. If the 600 kilogram car is travelling at 2 meters per second as it passes point A, calculate its maximum speed as it passes point B. Well, the kinetic energy at point B will equal the kinetic energy the car had at point A plus the loss of gravitational potential energy in dropping down this height of 24 meters. So we can say that half mass times the speed at B squared will equal half mass times the speed at A squared plus mg delta h, the change in potential energy. We can cancel throughout by m to get this formula. Then rearranging for v at B, we get this. If we then put the numbers in, we have a speed at A of 2 meters per second, gravity 9.81 meters per second squared, and the change in height of 24 meters, giving a speed at B of 21.8 meters per second. Part B. The car is actually travelling at 17 meters per second when passing B. If the car has travelled a distance of 40 meters along the track between A and B, calculate the average frictional force on the car. Well, the work done against friction is equal to the maximum kinetic energy minus the actual kinetic energy. That's the kinetic energy lost doing work against friction. So, work done is force or frictional force multiplied by distance, which is equal to the kinetic energy at the maximum speed we calculated of 21.8 meters per second minus the actual kinetic energy at a speed of 17 meters per second. So the force is equal to half times the mass of 600 kilograms times the maximum speed of 21.8 meters per second, all squared, minus half times 600 times 17 squared, over the distance of 40 meters, giving a frictional force of 1397 newtons, or 1.4 kilonewtons. Part C. If it is a further 20 meters to point C, calculate the speed at C, assuming friction stays the same. Well, the kinetic energy at C will equal the kinetic energy at B minus the work done against friction, and also minus the gain in gravitational potential energy. So, half times the mass times the speed at C squared will equal the kinetic energy at B minus the work done against friction minus the gain in gravitational potential energy. So, rearranging for the speed at C, we get this, and if we put in the numbers for mass and gravity and change in height, we get a speed at C of 6.2 meters per second.